Hello, students. Welcome to section on HL postulate, HL theorem. So I have one question for you. Is triangle ABC congruent to triangle DF? Okay. In other words, are they identical? So what do you think? So many of you would say the answer is no, because we have technically angle side-side, okay? So you would say no, because in this case we have angle side-side, okay? So you have parallel angles, another side, and another side. So the answer, you would say the answer is no, because of ASS, and we know we cannot use angle side-side. But be careful. Look carefully at the two triangles. Triangle ABC is actually a special triangle. Why is it special? Because it is a right triangle. Let me erase this because this is actually not true in this case. Okay? Look at the question below. Can we prove mathematically that the triangle on the left here is identical to the triangle on the right? And the answer is yes. Mathematically, we can prove that the two triangles are congruent. How? How would you get the value of x? Using Pythagorean theorem, if you recall, a squared plus b squared is equal to c squared. Mathematically, we can find the value of x. So you will get x squared plus 3 squared is equal to 5 squared. Okay? Same thing here. You get x squared plus 9 is equal to 25. So x squared is equal to 16. Oh, let me erase this. So x squared is equal to 16. And if you take square root of both sides, the answer is plus or minus 4. But in geometry, we cannot have negative distance. X is equal to 4. Okay? So this side is equal to 4. Now, if you do the same thing for this question, let's call this k. Okay? If you do k squared plus 3 squared is equal to 5 squared, same logic, k is also equal to 4. So the question is, are the two triangles congruent? And the answer is yes, because we have side, side, side. Okay? Because it's a right triangle, and if I give you the hypotenuse and the leg, automatically you can find the other missing leg. Therefore, today we'll introduce something called HL. So, hypotenuse leg postulate. Just so you know, so far we know side, 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 angle, side. Okay, we also know angle, side, angle, and we also talked about angle, angle, side. Okay, and we are not allowed to use angle, side, side, and we also cannot use angle, angle, angle. But today we will introduce HL, which works. So, if the hypotenuse and leg of one triangle is congruent to the corresponding hypotenuse leg of another triangle, then the triangles are congruent. So in other words, this stands for HL. So this will be HL. If I give you a hypotenuse and a leg in a right triangle, then we can show congruence. Okay? So HL is the last one that we will use. Okay. Let's see how we can use this in a proof. So given AB is perpendicular to BC. So in other words, this segment is perpendicular to this segment. So in your proof, you probably will say that we have a right angle. We also know that CD is perpendicular to DE. Okay? And we also know that C is the midpoint of AE. All right. So step number 2. Because AB is perpendicular to BC, okay, I can say angle B, the measure of angle B equals 90, okay? I can put right angle here, and I can also say angle D is also equal to 90, and what would be the reason? Okay, we have perpendicular lines, we have right angles. So we have perpendicular lines, means 90-degree angles. You can also say perpendicular right angles, you know, as long as you indicate that the angles are right angle 90 degrees. Okay? And then, since angle B is 90 and angle D is 90, I can conclude that angle B is congruent to angle D. And what's the reason for this step? I allow you to say all right angles are congruent. I allow you to say substitution. Okay, I will just say all right angles are congruent. Okay, so far I have a pair of angles, right angles. Okay, now what else do we know? We know that AB is congruent to CD. And I didn't mark the picture yet, so please mark it. And that was given. And also this was given. C is the midpoint of segment AE. C is the midpoint of segment AE. So look at this green segment AE. I am telling you that C is in the middle. So if C is the midpoint, okay, I can conclude that segment AC is congruent to segment CE. Why? Definition of midpoint. So step 4, please write AC is congruent to CE. Okay? And the reason, you could say definition of midpoint. I would just say midpoint implies or then two congruent sides. All right, so take a look at the picture. Okay, what do I have? I have hypotenuse. Okay, please remember this segment in green over here is hypotenuse because it's always across from the right angle. I also have hypotenuse. I have leg, and I have leg. So in this case, I can use HL. So your last step would be step 5. Triangle ABC is congruent to triangle CDE, and what's the reason? HL. Okay? So this is our first proof with HL. Okay, next proof. Given angle E and angle C are right angles. AB is congruent to FG. AF is congruent to BG. Okay? The question is, can we somehow prove that CB is congruent to EF? Just a little correction. This should say AC is congruent to EG. Sorry, please make this correction. Okay? So, first given, and please mark the picture. So angle E is a right angle, and angle C is a right angle. Okay? Then I have AC is congruent to EG. Okay, so the tiny mistake I made over there. So AC is congruent to EG. Okay, and we also know that AB, which is this segment, okay, is congruent to FG, which is this segment. Now, some of you may not see how this works, but I encourage you to redraw the picture. So one triangle will look like this, and the other triangle on top will look like this. So we know this, we know right angles. We know this side, we know this side. And I just told you that segment AB in red is congruent to segment FG in blue, okay? So they are also congruent. So if you look at this picture, we technically have HL, hypotenuse leg, because I gave you hypotenuse and I gave you the leg. So second step would be triangle ABC is congruent to triangle. Now, if I go with angle A, I have to go with angle G. Sorry, triangle G. Angle B, so I'm going to use angle F. And angle C corresponds to angle E. What's the reason for this step? The reason for this step would be HL. Okay, look at our goal. Okay, our goal is to show that CB, which is this one, is congruent to EF, which is this segment. Okay, in order to show parts are congruent, we can use CTCTC, which stands for corresponding parts of congruent triangles are congruent. Okay, we can use CTCTC. Corresponding parts of congruent triangles are congruent. And when do we use CTCTC? We use CTCTC after we show two triangles are congruent. So your last step, okay, will be segment CB is congruent to segment EF, and the reason for this step is CPCTC. Okay, so thank you for watching this video. Make sure you understand this. If not, you can replay it. Thank you.